Hello, math students. So I think one of the challenges that we still have is how to start certain problems, um, and save some time so that we can do the um, tests or exams in the allotted time frame. So keep in mind that when it comes to IB math exams, it is 1 mark a minute. So right now you're getting a little bit more, but in the end it's got to be 1 mark a minute. So I thought that instead of me straight away handing out the solutions to the Unit 3B test, I thought I'll solve them and video while I'm solving them, and I will try to be cognizant of the fact that I'm gonna talk my way through it so that perhaps you can see how I would solve these questions. Now, of course, I've already solved them because I already created a marking scheme, but I left it at school, and given my memory, it might as well be starting from scratch. So normally, of course, my screencast I are going a little bit quicker because I do the writing separate from the talking. But in this case, because I want to show you a little bit sort of the what we call metacognitive skills, I'm gonna go through it in real time um, with my tablet, which certainly doesn't help my handwriting. But let's see how we do. All right, so I'm gonna try to talk my way through this test. So okay, there we go. There we go. Okay, I'm starting. Question one: express 2 cosine squared x plus sine x in terms of sine x only. So right, I got to get rid of cosine squared x. Now that of course is a trig identity, so I'm going to not rely on memory. I'm gonna look at my formula booklet. Might as well. So here's my formula booklet. Topic 3 because that is trig. So I needed to get rid of cosine squared x. So, okay, good. So cosine squared plus sine squared equals 1. Fair enough. So cosine squared x plus sine squared x equals 1. That means that cosine squared x can be replaced by 1 minus sine squared x. Be careful that I don't make mistakes here. So 2 cosine squared x becomes 1 minus sine squared x plus sine x is going to be 2 minus 2 sine squared x plus sine x. Only sine x's, so I'm done. That's fine. All right, so solve 2 cosine squared x plus sine x equals 2. So of course that is the one that I've just written. So I can say 2 minus 2 sine squared x plus sine x equals to 2. So I can see that the 2's cancel out. I prefer my sine squared to be positive, so I'm going to put everything on the other side. So I've got 2 sine squared x plus sine x. I need to solve, so I need to find x's. It's worth 5 points, so let's have a look. I see a common factor, sine x 2 sine x plus 1. So there are obviously two solutions. Sine x equals 0 and 2 sine x so equals minus 1 over 2. All right, good. So I'm only interested in 0 to pi, so sine of x equals 0. It's the y coordinate in the unit circle, so I'm looking at x equals 0 and oh, I made a mistake, didn't I? Yes, I made a mistake because this is not going to give me any solutions, which is weird. So what did I do? Okay, I already see what I made a mistake. That should be minus. That should be minus because I put it to the other side, so this is plus. Now that makes more sense. Right, so radians, so this is pi. Okay, when is sine equals to a half? So sine increases very rapidly, so x is equal to pi divided by 6. And of course, sine is positive in the second quadrant 2, which is allowed, so that it is pi minus pi by 6, so that will be 5 pi by 6. All right, so 4 solutions. Good. Let's continue. All right, so y equals sine of x plus pi by 9. The graph of y intersects the x-axis, so that is y equals 0. At point A, find the x-coordinate of A in 0 to pi. All right, so 0 is sine of x plus pi by 9. All right, so if x lies between pi and 0, then x plus pi by 9 lies between pi plus pi by 9. So that's 10 pi over 9 and greater than pi by 9. Okay, so I can call this theta. So 0 is sine theta. All right, so theta is 0, so it's the y coordinate, or pi and minus pi, but I need to lie between pi by 9, so this is not allowed, and pi, so this one is allowed. Okay, good. So, but theta is x plus pi by 9 is pi, so subtract pi by 9 both sides, so 1 minus a ninth is 8/9, so 8 pi by 9 is a solution, only one solution, but then again it's only 2 marks. Very well. Okay, 10. It's translated up by 1. That makes sense because it doesn't go to there. And its period is gone from pi to 2 pi. Okay, good. Draw the asymptotes. It can only mean the vertical asymptote. So that is 1. That is 2. I want to make sure that they understand what I'm talking about. So sometimes they ask for equations, so let me give the equations as well. It doesn't really ask for it, but you never know. Better be safe than sorry. Okay, good. Write down the period of the function. Well, I already said that, didn't I? So normal, the period for 10 functions, pi divided by the number in front of x, which happens to be a half, so that is 2 pi. Oh shoot, I need to be careful. It's in degrees, so in degrees, should have done that maybe straight away. Put this on. So the period is 360 degrees. Okay, good. Okay, the value of f of 90. All right, so it's got 1 plus 10 of 90 divided by 2, which is 45. Oh, that's nice, because 10 of 45 is 1. So this is going to be 2. Doesn't make sense. 90. Yeah, that makes sense. All right, 2. Well done. Solve this equation equals to 0. Whew. Okay. Okay, so in other words, I'm looking for these things over there, aren't I? Man, that looks like it's minus 90 and 270 degrees. It's only 3 marks. I'm simply going to write it down. If I've got more time, I might actually show that it works. Using the graph, x is minus 90 degrees, I said, and 180 plus 90, which is 270 degrees. All right, good. But I'm going to come back to this maybe if I've got time. All right, good. That was that. Oh, okay. GDC allowed. Right, question 4. Let f of x be sine of 2x and let g of x be sine of a half x. Write down the minimum value of f. Okay, so f is sine, so that must be minus 1 because it can't be smaller than that. Okay, good. the period of g, so the sine, so this 2 pi divided by what's ever in front of it, which is a half. So this is 4 pi. It's in, oh, I can do radians or degrees. It doesn't really say, so I'm going to leave it in radius. Okay, consider the function f of x equals g of x. Find the number of solutions to this equation. So sine of 2x equals sine of 0.5x. All right, so I need to just a number of solutions. I can use my GDC, so let's do my GDC. There you go. All right, let's go. All right, so let's clear this. So sine of 2x and sine of 0.5x. I'm in radians, so that is good. I only need to go from 0 to 3 pi by 2. This seems to be appropriate. So that is, of course, my sine 2x. So my sine. So 1, 2, 3, 4. I see 4 solutions, so that's 4. All right. So using GDC graph, 4 solutions, and that's that. All right. Question 4 done. All right. Solve cosine 3x equals cosine a half x. Print 0 and pi. This is GDC, so I'm definitely going to do this with GDC. This does not look very nice. All right, so cosine. Okay, let's clear that. Cosine of 3x and sine of 0.5. Oh no, not sine, cosine. Cosine of 0.5x. Just make sure I'm still in radians. My window is 0 to pi this time, so pi. I can't go above or below plus or minus 1, so this seems to be fine. All right, so this is cosine 3x, this is cosine half. I need to find solve, so I need to find, so how many solutions are there? 1, 2, 3. Obviously the first one is 0, so that's easy. All right, x equals 0. I don't even need to do anything. So what about the other second calc? I need to do the intersection with this 5, curve 1, curve 2, closed guess, 0.1, no, 1.795. Okay, so x is 1.759, so this becomes 1.80. Okay, and now the other one, second calc, 5, yes, guess close to the intersection point, and 2.513, so that's 2.51 to 36 fig, so 2.51 x equal 2.51, boom, done. All right, good. So that was 5, 6. Okay. Consider the equation 4x squared plus kx plus 1 equals 0. Quadratic. For what values of k does this equation have two equal roots? Equal roots, that's something to do with discriminant, right? Equal roots mean discriminant is 0. So discriminant is b squared minus 4ac, so minus 4 times 4 times 1 is equal to k squared minus 16, and that has to be equal to 0. So k squared is equal to 16, so k is equal to plus or minus square root of 16, which of course is 4. All right, good. Oh, that was very quick for 3 marks, but yeah, corrects are important. So anyway, so good, two values. Okay. I let the function f of theta between 2 cos 2 theta plus 4 cos theta plus 3 show that this function may be written as 4 cos squared plus. Okay, so I need to do identity for cos 2 theta. All right, so let's. Where's my formula booklet? Cos 2 theta, and I want cos squared theta only, so I'm going to use this one here. 2 cos squared minus 1. All right, good. 2 cos squared minus 1. So 2 into 2 cos squared theta minus 1 plus 4 cos theta plus 3. Take away the brackets. I got 4 cosine squared theta. 2 times minus 1 is minus 2 plus 3. So that leaves me 1. And of course, the 4 cos hasn't changed. So voila, done. Alrighty. Okay, consider the f theta equals 0. How many distinct values for cosine theta does this satisfy? Now, of course, I can see here that this is basically this quadratic 4x squared plus 4x plus 1 yeah. So the discriminant is 0. So discriminant is 0. Therefore, for x has one solution if it's a quadratic. Therefore, only one solution for cosine theta. One solution for cosine theta because it just touches the horizontal axis. All right. All right. Find all the values for theta. All right. So 0 equals 4 cosine squared theta plus 4 cosine theta plus 1. It's 2 cosine theta plus 1 squared. Yes, because this is only one solution for cosine theta, which is minus a half. So, right. Right, so I have cosine of theta is minus a half, and I've got a huge domain. So rotation forward full circle, rotation backwards full circle. All right, cosine minus a half, so I'm looking at second or third quadrant. Cosine of a half is equivalent to cosine of a half is equivalent to, let's have a look, 60 degrees, right? Yes. So okay, good. So let's do forwards first. So 60 degrees, so 180 minus 60, so there's 120 degrees, and then again 180 plus, so 240, so that's going forwards. So there and there, so this is 60. So this is 60, that's going forwards. Okay, good. And now I can go backwards. So, that's interesting. So there's minus 120, so it's going this way. And then, okay, minus 240 degrees. Okay, that's cool. Right. Now, of course, this is paper 2, right? So do I have time to check? I'm doing okay for time, so let's check what I actually got this one correct or not. Okay, so what do I have? I've got, clear this. So I've got 4 times cosine of x to the power 2 squared plus 4 cosine of x plus 1. My mode is, I need to be in degrees. Alright, window. Okay, so minus 360 all the way to 360. I'm only interested in touching the x-axis, so I'm fine with this Y range, let's have a look. Boom, boom. All right, so, all right, definitely 4. Normally don't trace, but I'm just checking whether my answers seem to be correct. So, okay, let's have a look. Oh, yep, mine's 120, and oh yeah, mine's 240, and of course it's symmetric. So, okay, I am satisfied that that went fine. All right, question D. Given that f of theta c is satisfied by only 3 values of theta, find the value of c. Given that f of theta c, so that's a horizontal line, is so the function is equal to that value only 3 times. So there must be 3 intersections between that cosine function and the horizontal line c. All right, good. So let's have a it's paper 2. So let's have a look at so this is what it was, but this is not the full range, right? Because it's gonna go all the way up to 4. So all right, the domain hasn't changed, but I'm gonna go all the way up to 4. So let's do 4.5. All right, let's have a look. Oh, oh no, of course not, because it's 4 plus 1. So that's, geez, that's 9. So let's go all the way up to 10. Is that right? Yeah, so I can only set so any horizontal line can only intersect it 3 times. So, well, here it intersects 1, 2, 3, 4, way more here, it's 4. So the only way if I skirt at the top, right? So it's only if I hit the maxima, which happens at 9. All right, good. Right, so this only happens, so f of theta, see, 3 solutions. Well, if c is equal to 9. Okay, by GDC graph, whatever. All right, good. All right. All right. Whew. Question 7. The depth y meters of water in a harbor is given by this equation: 10 plus 4 sine of t by 2, where t is the number of hours after midnight and the units are in terms of radians. Okay, calculate the water of the depth at 2:30 in the morning. So y is equal to 10 plus 4. 2:30 means 2.5 hours. Okay, right. Right. So let's put it in my calculator, because who knows what this is. All right, calculator. I need to be in radian. And then let's say 10 plus 4 times sine 2.5 divided by 2. 13.36 fixed 13.8 equals roughly, well, let's use that, 13.8 meters. There you go. Oh, they even have a graph. So let's have a look. 230. Does it make any sense? 230 is over here, somewhere there. Oh, yeah, that makes sense. Okay, good. I'm happy. That seems fine. All right, so here's the graph for the first 24 hours. Write down the maximum depth of the water in the harbor. Oh, that's there, which 14 makes sense because 10 plus 4 is okay, good. Okay, 14 meters. Calculate value of t when the water is first at its maximum depth during the day. So that's there, right? So that is a quarter period. So the period, I'm in radians, it's set. So 2 pi divided by what's in front. So there's a half. All right. So it's 4 pi. So a quarter period. Okay, so t equals to a quarter of that, which is pi. Well, let's give a rough answer, 1.14 hours. All right, good. It doesn't ask for exact, but I might as well. All right, the harbor gates are closed when the depth of the water is less than 7 meters. An alarm rings when the gates are opened or closed. How many times does alarm? Okay, 7 meters. 7 meters. So this here. So 1, 2, 3, 4. So 4 times. 4 times. 7 marks. I better pay attention. Find the value of t when the alarm sounds first. So that's over there, right? All right. So it is 7 meters high, and it needs to. I need to find t for this. Okay. So this is ugly. So I'm definitely going to use my GDC. So GDC. All right. I'm gonna use the graph, of course. Mode. Let's do the mode first this time. I'm in Raiden, so that's good. All right. So clear. That is 7. That is 10 plus 4 sine of what is it? X by 2. X divided by 2. All right. So I'm around 7, right? So window. Okay. So this is 0 to 24, right? Oops. 0 till 24 hours, it said. Um, so, um, okay, so 0. I know it was 14, right? So let's just capture the whole thing, see if I actually get the graph. Do I get the graph? Yes. Good. So I need to find that point, second calc, intersection, yes curve, and then the first time that happens is around about there. All right. Okay, so 7.97, so 7.98. So T is 7.98 hours, so almost 8 hours. And that kind of makes sense, right? Yeah, almost 8 hours. Good. All right, 3. Use the graph to find the length of time during a day when the harbor gates are closed. All right, so from here to there, and from there till there. Okay, so this is roughly 8, and this is roughly 11, so this is roughly 3. It's symmetric, right? So, and it's only to the nearest hour. This is definitely, just make sure, yes, this is definitely close to 3. So this must be 2 times 3, 3 hours, right? So, yeah, which is 6 hours. I've shown in a graph that I've used it. So perfect. Good. Done. That was an easy 7 marks. All right, 8. Last question. One end of a piece of elastic is attached to a point at the top of a door frame and the other end hangs freely. A small ball is attached to the free end of the elastic. When the ball is hanging freely, it is pulled down a small distance and then released so that the ball oscillates up and down on elastic. The depth of D centimeters. Okay, that makes sense, right? So I've got a door, got an elastic band with a mass. I pull it down, so it's going to oscillate up and down. Okay, cool. All right, so this is the equation. Oh, shoot, it's in degrees, so pay attention. The greatest and least depth. Okay, well, that's easy. That is 110 centimeters, of course. 100 plus 10, 100 minus 10, so that's 90 centimeters. Okay, good. The time at which the ball first reaches its highest point. Highest point. So it's starting down, and then it's gonna go up. It's a cosine function. So what does a cosine function look like? A cosine function looks like this. So it starts at the lowest point, then it goes up. So this is the depth. So that's kind of weird, but this is the lowest point. So this must be the highest point, which is half a period, right? Yeah, that's half a period, because then it bounces back up. Okay, so period. Yes, I'm in degrees. So period is 360 divided by 500. Ugh. Do I know what it is? Yes, 0.72, isn't it right? Okay, let's not take any any risk here. 360 divided by 500. Okay, okay, good. That's good. 0.72. So here 0.72 seconds, and I need to find half a period. So therefore, at t equals 0.72 divided by 2, which is 0.36 seconds. Right, 4 points. That's a lot of points. That makes sense. Half a period bounces up. Yeah, that makes sense. All right, good. The proportion of time during one oscillation for which the depth of the ball is greater than 99 centimeters. Oh, wait a minute. Greater than. All right, so, okay. Okay, so this is a depth. So its highest was 110, I said. This was 19. Of course, it oscillates around 100. So this is 99 centimeters and has to be greater than. So this time, um, this time, and that time, this is one period. So this is 0.72. Okay, the proportion of time. Okay, let's first find the time. So I need to find this time over there, right? So I'm just going to use my GDC. So I'm going to say 99 is 100 plus, what was the equation? Let's make sure. 10 cos 500. 10 cos 500 t in degrees. So, all right, let's find this. Let's find this. Mode degrees. Better do that first. Right, so I've got 99, and then I've got 100 plus 10 times cosine of 500x. And I'm going to plot this for one period. That makes sense. So 0 to 0.72. That's all I need. All right, I'm gonna go a little bit below 90, so let's say 85, to a little bit above 110, so let's say 115. All right, good. Let's graph this baby. 99. All right, good. That makes sense, right? It looks like my graph, so I'm looking for this value. Second calc, 5 intersection, yes curve, close. Come on. All right. Okay, so 0.19148. Okay, so t is 0.1914. Let's not round off too quickly. Let's just keep more. 78. Okay, good. So that's that time. Right. So it starts from 0. So let's call this capital T1. So T1 is equal to that minus 0. So 0.191478. Okay. Let's call it T2, but surely T2 is totally symmetric, so yeah, it must be. So this is equal to T2. All right, so time above, time greater than 99 centimeters is T1 plus T2, which is 2T1, which is 2 times whatever that is. So, all right, 2 times 1.191478. All right, is 0.382956. 0.382956. 0.56. So that's a time above. So now we need to proportion. So therefore the proportion is this divided by the period, because it's for one cycle only. 0.72. Okay, good. So divided by 0.72. All right, so this is 0.5318, so it's 0.532. 236 fixed here, 0.532. So it's a little over 50%, and that makes sense because 99 is below 100. So it should be, it's 50% above 100, 50% below 100, so it should be more than 50% above 99. So it makes sense. Good. Okay, so let's have a look. That's it. I had one question I wanted to check, didn't I? So, which question was that? Okay, so this one. 10, 1 equals 0. Okay, so 10, 0 equals 1 plus 10 of x by 2. X by 2, which means 10 of x by 2 is minus 1. Okay, so, alright, so 10 is negative in the second and fourth quadrant. The reference angle is, of course, 45, because that's when sine and cosine are the same. Alright, so, and I've got a huge domain. One's forward, one's backwards. Okay, and it's x by 2 only. So let's have a look. And I'm only checking here, so let's make sure. All right, so this is 45, so I'm gonna go forwards, and of course this is 45, and I can go backwards as well. Okay, good. So, all right, x over 2 equals to going forwards is 180 minus 45, so it's 135, and then it's 360 minus 45, so 360 minus 40 is 320, so 15, and of course I can go backwards too. So backwards is minus 45, because that's when I'm right there, and then I'm going into what, minus 180 plus, so that's going to be minus 180 minus 45, so it's minus 225 degrees. All right, so that means that x equals to 270. 315 times 2 is outside my range, so forget about that. 45 times 2 is minus 90 degrees. Minus 225 times 2 is also outside my range. So yes, I had the right answers from the graph. So that's excellent. Good. That's it. I'm done. Voila. Let's hand this in. Right, students. So I hope this is useful. Took a bit of time to get through it, of course, but I'll upload this to YouTube, so you can just speed it up if you so wish. I don't have my marking scheme here, but I think I feel pretty solid about those answers. They make sense. I hope you noticed that I try to check where it makes sense, or in the sense that it does take a long time to check your answers. And that's it. That was sort of how I would work my way through this test. I did it in a sequence of the questions. Of course, you don't have to do that. But in this case, it was fine. All right, that's that. Take care. Bye bye.